Good evening, and welcome to PHONOPTICON, leveraging mobile advertisements to achieve state-level mass surveillance on a shoestring budget. I am Mark Milhouse. On the internet, I am Amnesiac. I started out as a 2651 Special Intelligence Systems Communicator Administrator. Yes, that's a mouthful. In the United States Marine Corps. And now I am the lead developer at an education startup based out of Chicago. I'm also a cyclist. And one thing that I want to get out of the way first, and I'll mention this again in the end, but we're hiring not a lot of positions, but if you're looking, or if you're not looking and you think you might be a good fit anyway, then go ahead and you can scan that QR code, and it has my email and everything in it for you. I think it's good to make a point that we're a non-infosec company, and we give a damn. So if you're somebody who wants to work for a company that's interested in securing their consumers' information, then. All right. So right off the bat, you guys all know what this talk is about. Question for you is: are any of you from an advertising company? I know there's at least one of you already. Yeah, you're laughing in the front. Last time I gave this talk before at Hope, and like 20 people raised their hands, and by the time that I was done, I didn't see any of them in the audience. And I'll also say I used to work for a law firm. I don't anymore. Either way, don't ask me legal questions. I don't know. And I think this part at the bottom here is wrong. I tried to copy it from the schedule on the site. So bottom line up front, as a digital society, we've built ourselves into an open ecosystem of bidding on ad placements based on geolocation and other sensitive information. So what I want you to walk away from this with is that the more personal information that publishers provide to advertisers, the higher the bids they'll receive for their placements. I want you to understand first that this can be used for surveillance. This isn't just some innocent thing that it works to help deliver advertisements. There's a way that this can be abused. Second, I'll show you how a system that takes advantage of that might be designed. And it's not for the purpose of you guys going out and stalking your exes. This is, we're trying to fix this here. And then I want to discuss with you a few things that we can do to fix this. So now you know, if that wasn't what you're looking for, here are your options at the bottom. Although I think that might be wrong, because it looks, from the schedule, it looks like... Awesome. Okay. I think track 1 and 2 are closed now, right? Yeah, so whichever one is 3, that's all you got left. All right, so right off the bat, I know that the title might be a little bit weird, so I wanted to explain why I chose the title Phanopticon. If you guys have ever heard of it before, there's a concept called a panopticon, which was coined by Jeremy Bentham. It's pretty much just everyone is observed. And the way that this works, you can kind of see this prison tower here. This structure is designed so that all of the inmates can be observed from one central location. And if you guys think that looks familiar, it's because you may have seen it before.
We're going to get out of here. We're going to need a few things. The guards wear security bands to control their ins and outs. I need one.
Leave it to me.
And on the wall back there is a Warnix battery. Once the battery is removed, everything is going to slam into emergency mode. So you definitely need to get that last. Or we can just get it first and improvise. Oh. Yeah. That's a big gun.
And the freeze frame was intentional, too. I also want to point out that soundtrack is how I plug in. Like that the soundtrack to those movies is amazing. So the previous job that I had, I did a lot of investigations. Some of the things that we looked for were privacy, security, compliance issues, fraud, and generally just other things that we thought were interesting. So this is kind of, this project, this research that I did was a little bit inspired by the way that we look at those kind of things. And when you're looking for those things, a lot of times you do app testing. So you're looking at web traffic. You might use Burp Suite or Wireshark. You might be looking at source code using JODX, which is a decompiler. And you might be looking at local storage. So you might be using like SQLite browser or something like that to read the databases or the raw data that's stored on the phone. For the purpose of this talk, I'm going to focus on Android apps because those tend to have some pretty interesting information. There are some. It's a lot easier to get to stuff on Android. And also for the purpose of this talk, we're going to be looking at mostly web traffic. Specifically, we use Burp Suite. And when you're in Burp Suite, you'll see something like this. This is in particular traffic from an advertisement. So this would be a bid request, and that information that you see there, the geo coordinates, some of the stuff that's blacked out would be like the advertising ID or referrer tags or stuff like that. And that is transmitted for the purpose of informing advertisers what they're bidding on. And then the advertisers would see this information, and then they would say, oh, I want to pay, whatever fraction of a penny to place an ad here. Yes?
If you have location shut off, does the GPS coordinates anyway?
That's a good question. So the question that he asked was, if the location is shut off, does it still share the GPS coordinates? I want to say no, but there's situations where that doesn't matter. A lot of the ad companies can still, using other information that they might have, they might still be able to derive your location. And a lot of apps, sometimes they'll cache your location. So if the app has already had access to it previously, it might still transmit that. It might be stale information, but if that stale data is your house, then transmitting that could still be valuable for them. So the bidding process looks something like this. What you saw before, that bid request, is the first part. It comes from your app, and it carries the metadata with it. It's sent through the ad exchanges to the advertisers. And then the advertisers, with their bid, their bid response, they'll respond with the URI of the ad and the tracking pixel. And the tracking pixel will have macros in it. And then the response to that would be for your phone or computer or whatever to send a request back to the advertiser for that pixel. And so that's the point where a lot of this metadata leaks in ways that was unintended, kind of. These pixel requests are then filled with that metadata. So people who weren't really intended to get access to that information along the process can have access to it. And this whole process happens while the ad is being displayed. So you don't even have to click on it in order to be divulging this information. Your phone will just do it automatically for you. So what was that? Oh, yeah, right, yeah. Everything's taken care of for you. So the first thing that I saw here was that there's a lot of JavaScript involved in this process. And I thought to myself, maybe I can get the phone to do some interesting things by injecting code into this JavaScript. So in Burp Suite, you can use the interceptor to pause a message before it reaches your target. And you can go in there and insert some JavaScript. And the reason why that works is because these advertisements are usually displayed in something that's called a web view. Who here is a Java programmer or like an Android programmer? Familiar with web views? So web views are pretty much just like a micro instance of a web browser that you can build into an app. And don't think of it as like a way to show like a whole web page. It'd be a way to render like an iframe, or you could even use a web view for something that's not rendered on the screen. So they render HTML, CSS, and JavaScript. They might even be able to do Flash or Java depending on how they're made. And they're generally inside the Android app itself. So the source code for the web view is inside the source code for the app. They typically inherit the permissions that many apps legitimately need. So, for instance, if you have like a weather app, then the web view that your advertisement is displayed in would have the same permissions that the weather app does, unless you did something to preempt that whenever you wrote the code for that app. And so what that means a lot of times is the advertisement will get the permissions that the app has, even though the advertisement doesn't necessarily need to have those. So this can be pretty dangerous because it means that you don't realize that you're giving up that permission a lot of times. And you're giving it up to a third party that you've never really had access to, or an interaction with, and a lot of times you don't even have a contract with them. So this is something that's commonly leveraged in malvertising. I think that a lot of you guys are familiar with the concept of malvertising, but it's just another portmanteau. Our industry's rife with them. It's exploiting loopholes in how the ads are displayed in order to gain unauthorized access. One of the most common versions of that is drive-by downloads, but that's not all. There's a lot of things that you could be able to collect. For instance, information from the computer that you can access using JavaScript. And no special frameworks either, just vanilla JavaScript. You can get the name of the app, the battery level, you can make it vibrate, and you might, depending on the permissions, as I mentioned before, you might even be able to access the location. So my first thought was, if I can access this information through the web views, maybe what I can do is just tap into the location manually by delivering ads that have in their JavaScript these like geolocation collection functions. So it's pretty simple to get the geolocation. You see here it's just a few lines of code, and then so I thought I'd give it a try. And first, what I did was I injected something like this with an alert message into the screen, or into the advertisements, the traffic as it was flowing, and it worked perfectly. So I thought that I'd try it out. So I went and found a cheap Russian ad platform, and I bought some ads on it. And I got some pretty inconsistent results, and then I got rejected. So my campaign was banned. They said rotating tags, auto-download, auto-install, these kind of things are prohibited, which I thought was kind of surprising considering the reputation that these ad networks have. But what I decided to do was figure out how to get the ad approved first. So I think I should backtrack a second here. Before I started this research, I had no experience with advertising whatsoever. So it was just kind of, I was curious. I was working my way through the industry and really starting to understand how this stuff works. So get the ad approved first, and then I could sneak the JavaScript in later, and that's how I got banned, was because you can't. A lot of times what they do is they fingerprint the advertisements, so that they know if you're changing it after the ad's already been approved. So I figured if you're going to pass QA, what you need is legit looking ads. They need to be somewhat believable because sometimes they do have humans looking at them. But one thing that was important for me was that it was boring, because I didn't actually want anyone clicking on them. I didn't want anyone looking at the ad and either thinking, wow, that looks suspicious, or looking at the ad and thinking, wow, I want to make him have to pay more money, because if you pay per click, if nobody clicks on it, then it's a lot cheaper. But if people do click on it, then all of a sudden you're paying a lot of money. Well, a lot more. It's still like hardly anything. I figured another thing, a lot of times what I was finding in the process was that they would click through, the QA people would click through and check out your landing page. So I added some content. I made it HTTPS. And then, of course, like I mentioned before, just don't do stupid stuff. So don't, swap out your code. Don't do redirects. A lot of times that's what you see on like the lower quality ad networks. And that when you're trying to do things on a more legit ad network, it gets you in a lot of trouble. So this is kind of the progression of advertisements that I had. Yeah, so, the first one was a little bit 1990s, and then I went for a redesign. I have run these at some conferences, so if any of these look familiar to you, then that would explain it. And I think later on you might understand why I would run them at the conferences, kind of as like a test proof of concept. And this is what the landing page looked like. And the countdown actually worked. So it kind of gave you a little bit of a notion that there was something going on behind the scenes. And if you think, what's the countdown timer for? It was actually just like a hard-coded value that it started at. So every time you refresh the page, the timer would restart. And it worked. it got approved, and I got almost 100,000 impressions with it. And I got to test a lot of different iterations of my code and see what would be successful and what wouldn't. But one of the things that over these 100,000 impressions, each one, probably once every like 2,000 or 5,000 impressions was a new iteration of my test. What I found was that I was getting really inconsistent results. So I realized the ads are cheap. Bypassing quality control, it's not nothing. Like there's things that you need to do, but it's still pretty trivial. But what I was finding with these Russian ad networks was that the GPS access isn't guaranteed. So only about 1% of pizza were also interested in saving pizza. So the GPS method on JavaScript has a lot of pitfalls. You need the permission, it's asynchronous, and not all of the devices work the same way with it. So I figured that using that function and using that network that I was on before might be a little bit problematic. So the question, would it be possible for an attacker to build a surveillance system that uses mobile ads to track a user's location? And I think we all know the answer to this question. I guess the better question is, how do we do it? So we need a few things. One is we need to be able to deliver ads. And we have the demand-side platform, which was kind of like that, I was saying before, that Russian ad network that I was using. We also need to be able to programmatically interact with it. The point of that is so that I'm not constantly trying every time that I need to update who my target is, or every time that I need to update what ads are running. I'm not doing that all manually. So a lot of the ad platforms have APIs. We need to be able to identify a target uniquely. This is a pretty easy one. So all the advertisers allow you access to the ad IDs and device IDs. But now we have a handful of new problems to solve. One is that we want to get the location consistently. The other one is that we want to be able to resolve a target to a person. So if I have the ad ID, I can target advertisements to that device, or I can target advertisements to that user. But I don't know exactly who that person is. And then later on in the process, I also want to be able to verify exactly who that person is over and over again. So maybe the ad ID might change, but is there other information that I can use to make sure that I'm still hitting John Smith every single time? So for the first one, I found an article that said, this is from Wired.com. And at first when I saw this, I thought, oh my god, I've been scooped. So they had come up with this process using grid-based surveillance, where they could buy targeted advertisements against a specific location and an ad ID. And then every time that ad is displayed, they would know that that person was at that location at that specific time. So when I read the article, I saw this is one of their examples. And what I realized was that this is a pretty convoluted system, and also their $1,000 price tag is pretty high. I thought, maybe we could get that price down. Maybe we could get it way down. And an attacker wouldn't really want to build such a complicated system. A lot of the people that are interested in this kind of stuff might not be so tech savvy. And also, I knew that you could just grab somebody's location. You could use JavaScript, or if you guys are familiar with the ad industry, maybe Emerald, or the easier one, tracking pixels. And so that's what we're going to focus on today, because as I mentioned before, that already has a lot of that information in it. So here's how tracking pixels work. You'll have that URL that you'll provide to the ad platform, and like I said before, whenever a user requests the ad, or whenever your phone requests the ad for you conveniently, the tracking pixel request is also transmitted with that info. And the advertiser receives a request, and they can store that data for marketing purposes. They can use it for whatever they need to. So sites, a lot of times they have more than just latitude and longitude. Some of them will provide up to 6 digits of precision for that geolocation information as well. These tracking pixels alone are enough to do some pretty specific surveillance. And it doesn't require the target to click on the ad. As long as the ad is displayed, then the attacker gets the information that they requested. So I didn't really want to bore you with a bunch of pictures of geolocations that people don't realize that they're giving up, while I ramble on endlessly about how this can be used to identify people in their home, their routines. And I'm not going to dwell on the fact that this information can be used to identify vulnerable groups of people, who they are, how they communicate, or where they live. I think you could probably imagine a lot of the apps that people use that might be giving away this kind of information. And that's not really what I wanted to focus on today because, like I said before, we're trying to find a specific individual. So we have tracking pixels to get the geolocation, we have the ad IDs, we have the API so that we can programmatically interact with it, and we have the demand side platform, which is going to be how we make this all happen. So what's next? We need to figure out how we're going to resolve a target to a specific person. So who exactly are these people? So I found an article about inferring users' identity using location and time. The researchers did a survey over 1.5 million people over the course of 15 months. They pretty much had access to cell phone towers for an entire city. And what they found was 4 data points with about an hour of temporal resolution yields about 95% accuracy. So if you think about it, by the way, it's worth noting that these data points are cell tower range. So I'm not, is anyone here a mobile communications engineer by any chance? Okay, so how far are you from a cell tower when you're using it? Like, what's the max distance? There we go. So even with a couple miles of resolution, there's still, if they have that hour time resolution, they can verify you up to 95%. So now we know how we can resolve the target to a specific person. And then the last piece of the puzzle that we need is to verify a person's identity. We can do this using device fingerprinting. It's not perfect, but it's good to eliminate all the negatives. For instance, if you know your target uses an Android phone, then it's improbable for them to have machine fingerprint that matches somebody with an iPhone. Now, I don't use device fingerprinting much, but I did pull this up on my phone and one of my coworkers' phones, and we had the exact same model. So I had the iPhone 7. He also has an iPhone 7, and our fingerprint was exactly the same. I didn't look at the individual values either. So now that we have all the pieces that we need, how are we going to put it together into a surveillance system that we can use to track a single person? So pretty much the way it would work, maybe an attacker knows where your house is, where your work is, or your dry cleaner, where you go to the gym, or where you go to church. You could pretty easily list all these different places, and then advertise to everybody that's in these locations. They would add all of the suspects to a list and target them specifically with different ads everywhere they go. So everybody that matched all of these different locations would be a suspect. And then you could track them as they move around. Then as you watch their behavior, you could narrow down the list further and further. Once you have that device ID, eventually you have one person, and that device ID you can then use to follow that person as long as that device ID stays with them. A lot of people don't know that the device IDs are actually or the advertising IDs are actually changeable. That's something that you can do. If you have an Android phone or an iPhone, you can go in there and change your Google Ad ID or your Apple Ad ID. But I'll show you a demo of how a system like this might actually work in the real world. So this is my hometown of Chicago. And oh, you know what? I need to put this on the screen over there. I know, right? All right, this is my hometown of Chicago. And up here you can see, little known fact about me is that I live in Wrigley Field, right smack dab in the middle of it. So that's going to be Mark's house. The dugout. It's concrete, so it's not that comfortable, but they kicked me out of the locker room a long time ago. So let's see. I'm home from 6 o'clock in the evening to 8 o'clock in the morning. Not 25. And, alright, so there's my house. And then scrolling down here, anyone from Chicago? Oh wow, a lot of you guys. That's awesome. See you guys at ThoughtCon next year? Let's see, down here, Merchandise Mart. Anyone work at Merchandise Mart? We're going to pretend like I did. Alright, and then, 200 meters or so. We'll assume that is pretty accurate. I'm at work from 9 o'clock in the morning and to 5 o'clock in the evening, because I'm a clock puncher and I don't stay any later. Alright, there you go. So, let's zoom out a little bit here. Where the controls go. Alright, so now you can see, here's my house, here's my work. This being a proof of concept, I'm not going to go any further than that, but we'll assume that that's enough information. We'll say that's 4 data points, right? We know where I am in the evening and where I am during the daytime. So we're going to go ahead and submit that. And now you can see a few of the data points that we have on me. This might be, for a limited time period or something. But ultimately, if you were collecting data over a long enough period of time, if you were maybe tapped into the back ends of these systems, you'd be able to do something like this, looking over much greater periods of time. And so, here I am at Ohio Street Beach, hanging out in the sun, and at the zoo, visiting the animals. So, some other ways that you might be able to use this type of information. You can see, so I've removed the ad IDs for all the different people, but what you can see here is when they're at different locations, right? Who's using, maybe it's a website, maybe it's an app, what apps people are using. And you can just kind of toy around at these. Yeah, so you can see a lot of things about who's using what and where. So that the bundle ID is the name of the app. So loveframes.romantic. I wonder what that is. And there's a lot on here. There's a lot of antivirus apps. There are a lot of security apps. There are some lifestyle apps. Some companies that definitely should not be divulging what their user base is, and certainly not divulging who specific users are. Here's my cursor. Let me get that back. Yeah, so these in specific are data points from my research. I anonymized them for the purpose of displaying them here. All right, one thing that I want to point out, a conversation that I had earlier today highlighted something that where this could really play in, and I think it's worth bringing up. Does anyone here work for the government? Any 3-letter agencies? Say, there's like an FBI stakeout or something like that. If you're a savvy criminal and you want to, track if anyone from a government agency's hanging out around you a lot, then you could very easily show advertisements to, places like FBI headquarters or something like that. And because we all know that OPSEC is not very tight, that could very easily trigger, you could set it up to trigger an alarm if, the same ad ID shows up near your house or something like that. It might trigger alarm a lot more than you think it would. But it could definitely be, it could definitely be a way of abusing this system and the way it's designed. So now we get into the real point of the conversation, right? How do we fix it? And I invite you, once I get around to the questions portion, if you have any potential solutions, something that you think I might have missed, or questions about how these work, go ahead and ask them or pose them. So here are the stakeholders that really have the ability to have an impact on this. The ad industry, operating system developers, app developers, security professionals, and users. So it comes down to one of the biggest ones is the ad industry. And I would say, as owners of this technology and stewards of your customers' privacy and security, it's your responsibility to protect their information. 6-digit precision isn't necessary for almost every single ad campaign ever. And even the difference of a few hundred meters could make an enormous impact on the efficacy of surveillance techniques. Make sure that demand-side platform is upholding their commitment to user privacy and safety, and is tempting to bow down to the demands of the advertisers. But they're always going to want more. They're always going to demand more data from you so that they can, make better bids. And there has to be a limit somewhere. Some things that you can do is to draw the line saying that the advertisers have to set perimeters instead of just giving the advertisers the location information. This might not dissuade that $1,000 surveillance campaign, but it could definitely frustrate the efforts somewhat. The research that I showed you today, that only took probably the entire research took only like about $100. If you were to do a targeted campaign with this, you could probably do it one person for $5, something like that. It's tempting. Sorry. On to the next slide. So at the operating system level, I found one study that I think is amazing. It's a research paper by Pierce, Porter, Felt, Nunes, and Wagner. I think you might recognize some of the names in that paper because some of them have gone on to have some pretty prominent careers in InfoSec. But they requested that you require separate permissions for a location for advertisements. So if an app had the location permission and then there were advertisements displayed inside of that app, then there would be one permission for the app to get location and then a completely different permission that people can reject for the advertisements to get locations. I know that that's something that the advertising companies might not like so much, but as somebody who's a mobile phone user who sees advertisements all the time, that would be awesome. And it really gives the users the ability to control specifically what's going on. So this might look something like this at the operating system level. I'm not going to get into the details of this. You guys can parse that on your own, and if you're really interested in that, I would recommend you check out this paper. I have a list of references at the end of the presentation. So app developers, you really have a lot of control over this as well. You can protect your customers. You're really the front line of defense for them. And one way that you can do this is view all third-party code as dangerous. One thing that my company is hopefully an example of a way to have this forward-thinking mindset, but make sure you employ security professionals, whether it's contracting outsiders or whether it's hiring insiders or both. Facebook, for instance, says that they'll never charge money for their service, but maybe a paid opt-out is just what we need for these kind of things. The ability to decide that you just don't want advertisements shown to you. I know that creates some other problems, especially when it comes to economic disparity, but that's a conversation we should probably have. I don't own a tech company, and I don't report directly to investors, so I don't know a lot of the woes that tech companies experience. So I totally get it if there's pressures on you from your investors to do stuff like this, but you also have to keep in mind that if you're not serving your customers, then you're not going to have revenue. So security professionals, and this is pretty much all of us in the room, right? We're really the eyes of the company. It's critical that we speak up about features or issues that are concerning or make you uncomfortable. It's important that we make noise. Don't let your clients and employers be blinded by profit. And remember to encourage them to stand up for their customers. Information can be encoded or encrypted. It can be broken up and displayed in chunks, or it can be transformed. So when you're testing, make sure that you're not just using automated processes, but that you're also manually going through to check for data leakage and those kind of problems. And one thing that we can do, if this is something that concerns you, you can step up and you can support legislation that restricts the collection and distribution of sensitive information. And then users. I do have to say it's not your fault. This is something that's way out of your control. A lot of the stuff that we use on a daily basis does this without us even knowing it. So let me emphasize that this is only going to get worse. Let me reiterate what I said before. If this is something that concerns you, it's important that we support the organizations that are fighting for those privacy controls. Some things that you can do up here: ad script blockers, false accounts, GPS spoofers. These kind of techniques aren't necessarily 100% effective. The question came up before if it was possible that the location is getting sent even when you have it turned off, and that's very likely. It's likely not necessarily that it's being sent, but that there's other ways that they can identify you. So here are some of the organizations that are pro-privacy that are working to get this changed. I will say that I'm not 100% against advertisers having access to geolocation information. I just think that the way that this is set up is problematic, as I illustrated before. So here are my references. These are all of the different articles and research that I used in making this talk. And I'll wait for the phones to go down before I go to the next slide. Actually, I don't know the answer to that question. But if they are, I'll tweet it out for sure. Sure, yeah. So he said everything's being recorded. The slides will definitely be part of that recording. There's another question? Oh, okay. All right. Yeah. So closing remarks. We, sitting in this room at this conference, in this industry, we represent a comparatively tiny collection of people who truly understand the dangers of things like this. This is a real problem that affects every member of the digital society, and it's not going to get better. We need to work on improving our own systems and holding our service providers to a higher standard. And I have one last video, if I can find my cursor.
Beautiful. Beautiful. Unethical. Dangerous. You turn every cell phone and document into a microphone.
And a high-frequency generator receiver.
You took my sonar concept and applied it to every phone in the city. With half the city feeding you sonar, you can image all of Gotham. This is wrong.
I've got to find this man.
At what cost?
The database is now key encrypted. It can only be accessed by one person.
This is too much power for one person.
That's why I gave it to you. Only you can use it.
Spying on 30 million people isn't part of my job description.
This is an audio sample. If he talks within range of any phone in the city, you can triangulate his position.
I'll help you this one time. But consider this my resignation. As long as this machine is at Wayne Enterprises, I won't be.
When you're finished, type in your name.
And another intentional freeze frame. All right, thank you guys very much. Just a reminder, we're hiring. Like I said, if you guys are interested, go ahead and snap that QR code, take a picture, get my contact information. And now, if you guys have any questions, I'm ready to answer them. In the back. Sure. I'm sorry, if they have to what? Yeah, so that, in theory, you're correct. What he said was, the implication is that they would have to actually be looking at an app on their phone in order for the advertisements to be loading. I think in theory that makes sense, but I would imagine there's probably situations where that's not the case. I think it also depends. So I focus on advertisements here, but there's also situations where there's other tracking libraries that might be in use, and so that for the purpose of what I was talking about, the specific setup of my system, yeah, you're right. But then there's certainly going to be other situations where that's not the case. Just behind him. You sound like you work for an ad tech company. So he said you have to be on the same ad network as. Yeah. I should have thrown that in there. So there's like this map that you can find of the entire ad industry, and there's so much stuff that if you put it on a screen like this size, you still won't be able to read the text. So you're right. There are some, really the level that you or I would interface with the ad industry is the demand side platforms. That's where we would go to buy our placements. And these demand side platforms, some of them do have relationships with almost all the exchanges. So if that's, if you were trying to make sure that you had a really high likelihood of hitting your target, then you'd probably want to find a DSP or use multiple DSPs, but you'd probably want to find DSPs that have the most partners. Back there. Sure, you might have missed the first part of my talk. I really have no idea legally, but I think no, that's fine. I would say that outside of like legal implications, one of the easiest ways that you can figure out if there's any kind of obligation to you is look at the privacy policies and the terms of service. And one of the things that you'll find there is that a lot of times they kind of vaguely mention third parties. So that that might work as like an umbrella catch-all, but I think it also depends on. Anybody here have a law degree? Okay, then maybe you can find somebody else. Actually, I would say if you're looking for an answer to that question, go hit up like the EFF because those guys would definitely be able to answer that, and especially if you could find a specific situation. So maybe like show them a privacy policy and be like, hey, is this situation above board? Any other questions? Sure. Okay. Sure. And that's one of those things that that's interesting because my question would be, how can somebody who has your information not have a legal relationship with you? It's like somebody walking around with your social security number. Like, do they have a responsibility to protect that? So that's a good question, and I think that's one of the things that the legislation's trying to answer. And like I said before, that slide that has all those different organizations that are trying to help improve the situation, that's probably a good place to look for answers to that. Any other questions? Oh, I have one in the back. So that's the point of the design of the proof of concept system, was looking for one specific person. There are a lot of different ways you could do this. But I think if you were to follow what I did, from beginning to end, you would end up with data about a lot of different people. But the end result would be, of course, you'd want to find that one person in the noise. You'd want to find the signal in the noise. And so that's kind of that, when I put up that web page that I had made, the point of that was to show that you could use those specific locations for an individual that you know some pre-identified information for, and then be able to pull that person out. And then, so once you have the identifiers for that person, then what you can do is feed that back into the demand-side platforms and tell them to just advertise to that person. And you can even tell them, you can set the bids really high. You can tell them to advertise on, every app. You can say there's no limit to how frequently you want it to show. So if you wanted, if they were using an app that was on the network that you're working on, and that app frequently showed advertisements, you might be able to get every single placement. It all depends. But yeah, I mean, that can work many different ways. You could collect information on many people. I think there are, entire industries built around collecting information on everyone. And then there's, you could, just kind of hone it down to just one person. Anyone? Oh, more questions. Yeah, I mean, if you have unlimited resources, this stuff, yeah, you can see that. You can see that there's international data. I was trying to keep the budget as low as I could, partly for the reason that I wanted to be able to say that, for under $100 I did this. But yeah, if you wanted to be advertising in other countries, I think where this is probably going is GDPR. Sure. Okay, yeah. That's actually, that is a good point. I think the military probably has better ways of doing this. But if they wanted to, this would work. I mean, obviously it works. Does that answer your question? It does. I think, I would say that I wouldn't worry about this, because for somebody doing real state-sponsored mass surveillance, this is a really convoluted method. Advertisements aren't necessarily, if I wanted to go out, if I had a huge budget, and I wanted to go out and buy ad data from these networks, if I had the money for it, they'd sell it to me. So yeah, you could definitely track all sorts of things with that. One last question. Sure.
One of the ways that location reaches has directly impacted policies by revealing U.S. secret military systems.
Yeah, you're talking about the...
How do you look at it and find out where things are?
Sure, yeah. I think you're specifically talking about the workout apps, right? And that was pretty crazy. I think there's no question. I've seen a few places, I won't name places in specific, but I've seen a few places that I had holes in my GPS data. I don't know why. But I think there are probably some controls to prevent data leakage, maybe where it's really critical. But there were also other places that I expected not to see data, having seen holes in the past. And the holes might be for other reasons too. There might be electromagnetic interference, or it might just be uninhabited or something like that. What was that? It might be. That would probably be from EM noise, right? Because it's so dense. Okay. Sorry. Yeah. So, yeah. I mean, I think that's something. I know that the government's aware of this kind of stuff. In some of my when I was working on this, I did ask a few people, this was OPSEC things that they worked on, and okay, so I'm done. But I will say that that's something that we need to be better about controlling this kind of information flow.